Hello, this is Mike McCollum with WildCat Solutions. We're a system integrations company that helps companies with their maintenance issues. Today we will be talking about thermography. If you have any comments or questions, please add them to the comments section below. Thermography is where we record the heat radiation coming off of a device. The advantages is you can extend the life of your equipment, reduce the downtime, increase your electrical reliability, identify potential existing issues before they fail, and testing is performed during full operations. The disadvantage of thermography is the images can be difficult to interpret. Accurate measurements are difficult due to differing emissivities, focus, and reflections. Thermography cameras cannot read underwater objects, and thermography imaging cannot see through glass. Kirchhoff's thermal radiation law states that when an object is exposed to thermal energy, it comes in three components: reflective, absorbed, and transmitted. White body objects have very high reflective and very low absorbed and transmitted energy, where black bodies have very high transmitted energy and very low absorbed and reflected energy. This is where emissivity comes into play at. Emissivity is the ratio of radiation of heat from a gray body divided by radiation of heat from a black body. The higher the emissivity number, the better the object is at emitting heat radiation. In the chart below, we show some common emissivity numbers for different objects that we would be taking pictures of. As you can tell, there's a very wide range, and this is why it's so critical to set the proper emissivity number in the camera before starting the thermography survey. Now we will review some of the types of failures that thermography can reveal for you. In this particular example, we have a faulty connection, commonly referred to as a hot joint. AR1 has a maximum temperature of 319.4 degrees F, where the connection to the left of it, SP1, has a temperature of 106.0 degrees F. These types of connections are typically rated for 90 degrees C or 167 degrees F. As we can tell, this one's very hot and needs to be repaired. This is an example of an overloaded breaker. As we can see, the three wires coming off the bottom are all hot and they look about the same temperature. This is where we need to take a amp reading to validate that we actually are getting a good reading and determine what is causing such high temperatures on the bottom of that breaker. This here is an example of an open wire. We're not looking for a hot reading here. We're looking at the cold reading. As you see the three fuses, the one to the right is very cold, where the two of them to the left are much hotter. This is where we need to take an amp reading and validate what is causing this reading to be so cold. This is an example of a failed disconnect switch. As we can see, SP1's at 179.2 degrees, where SP3's at 170.0 degrees. So the heat being generated is at the knives. So those knives need to be determined what needs to be done to repair them. This here is an example of an overfilled cable tray. As you can see, we have hot spots all through the cable tray, so this is an indication that the cable tray is overfilled. The plant will have to decide how they want to address this issue. This is an example of an undersized fuse. As we can see, the hottest spot here is the fuse to the left. The connection below was hot, but not as hot as the fuse, and the fuses to the right are much cooler than the fuse to the left. This is two examples of unbalanced loads. We'll first look at the breaker on the left. As we can see, all three wires coming in and out of that breaker all show different temperatures. We would need to take an amp reading to validate that this is truly the case. On the right, we show three single-phase transformers, and all three show different temperature ratings, which is another indication of an unbalanced load. We would once again have to take amp readings to validate this is true. This is an example of a breaker contact that has failed. As we can see, the breaker in the middle there is hot. This is an indirect reading, so we have to be very careful to make sure that we validate this. This here's an example of a battery that has failed. As we can see, the plates in the battery are very hot. Thermography can determine a number of issues with batteries, but normally when you find a failed battery, you just change the whole battery out. So we're not concerned about why the battery failed, just if we have a bad battery. As we can see from the examples, thermography can reveal many different types of issues in your electrical system. WildCat Solutions has the expertise to perform this and to validate your issues and provide you a reliable report on what needs to be repaired. For more information, contact WildCat Solutions.